Well, it's an immense pleasure, and I want Mr. Dura to stay here for a minute. I want to start out with thank you, and this will not be possible without two very important people. So please come over here. You started something, you were ambitious. A lot of people have ambitions, but very few people can take the ambition to the next level and implement. And it takes discipline, it takes courage, it takes maturity. So I respect you a lot for what you have done. It's a wonderful show you have created. Proud to be part of it, so thank you for creating it.
So if you have started, can I talk like a minute more? So this year I wasn't alone. Usually I was organizing alone the conference with some help from other people. But this year there was many more people involved. My wife, my brother-in-law, my sister-in-law, so like whole family, probably even my father and my father-in-law as well. My gosh.
Are you adopting more people?
Yeah. So if you want to join my family, just please come by. But it was not only this. Wojtek Robotowski, who has to leave on Monday, and Maciek Opioła, who guys from the Warszawa had to leave, but there are two other people, Adam and Michał, who is still helping us take care of that. Oh, here he is. Please stand up. And Krzysztof, you can stand up as well. So thank you guys as well. So after we finish the third keynote today, we'll sign the adoption form and this newest addition to the family. So thank you guys. Big thanks for you. And if you want to join us and help us grow this conference even bigger, please send me an email, and yeah, that's probably all. Thank you.
Excellent. Well, the other person, yes, go ahead. The other person I want to thank you is the people in front of me. You made this happen, because if you didn't care to be here, to learn, to share your passion, none of this would work. So I want to give a round of applause to everybody around you. Thank you. And I want to do one more thing before I get started with, if we can switch over to the presentation slides over here. I want to do one more thing. I asked the lights to be on for a reason. I want everybody here in this room, just for a few moments, to just stand up. Just stand up. We've had lunch, so we can kind of stand up a little bit. Just a little stretch. There we go. And I want you to look around, right? There's well over 1,000 people around you. Just look around for a minute. And what I want to do is, I want you to stand up, keep standing, don't sit down yet. But I want you to sit down if you're not a programmer. Seriously? Okay. I want all the men in the room to sit down. I want the ladies to be standing up. You get to stand up. I want the ladies to continue to stand up, but if you're not a programmer, I want you to sit down. That's awesome. And I want one of the ladies to volunteer to come and speak here with me today. It's your choice. Who's going to be here? Her? You've been volunteered. Awesome. I request the other ladies to sit down. Pleasure to see you. What's your name?
I'm Maria.
Maria, glad to have you here. You get to speak in this one.
Okay. Wow.
Once we figure out how that works. It's on already, so we just need to speak and they will turn it on. It's up. Okay, excellent.
Yeah, it's on.
Maria, what's your name?
My name is Maria.
Excellent. Well, good to have you here. So what do you do? You program? What do you do? Just a little bit
I program in Java,
All right.
Mostly backend programming, and also a bit of front-end programming.
Excellent.
Recently in Angular.
Oh, wonderful. Are you nervous being up here?
Yeah, a little bit.
Yeah, I'm nervous every time I'm here too. That's why I asked for a company. This feels a lot better. Excellent. Well, I'm going to kind of ask you some stupid questions along the way, if you don't mind.
Okay.
She's like, I'm used to it at work. Okay. Well, I'm going to get back to the slides for a minute. I want to think about this word, mainstream. Let's think about that for a little bit. What is mainstream? Mainstream is what most people do. Like everybody around us does that. That is mainstream, isn't it? Now, let's think about mainstream for a little bit. So, we've been doing it wrong. Really wrong. In so many ways, so many times, in so many levels. And sometimes we don't even realize it, that we are doing it wrong. So here's my first stupid question for you. I'm going to take this ball way up there, if you can see it. I'm going to toss it down. What is it going to do?
Bounce.
Bounce. And eventually?
Stop bouncing.
Stop. Why does it come down instead of going up?
Why does it go down?
Yeah, why does it go up all the way rather than coming down? I told you it's a stupid question. Why doesn't it fly away? Why does it come towards Earth?
Because we have gravity.
We have gravity, of course. How do you know it, Maria?
From school.
And who told the school?
I think scientists.
And which one would be blamed for that?
I don't remember.
That's okay. I don't remember a lot of things either. Guy called Newton, they often say, rings a bell?
Yeah.
But Newton is one of the coolest guys in my mind. And we attribute this to Newton a lot. Hey, that jumped away. Okay. Well, it actually turns out, this was even a long time before that. Another cool dude called Aristotle. This was one of the greatest guys, other than Newton, of course. And he kind of said, you know what, this is kind of funny. Things kind of fall to the ground. And they fall because they're heavy. And that's where the word gravity originated from, gravitas. And he said this in 4th century BC, a long time ago, right? In 4th century BC. And then nobody cared about it. And then eventually a guy named Bhaskara kind of coined the term back in about 11th century. That was a long time ago, when actually Indians did something useful, right? And then again, this guy called, you know this dude, right?
Yeah.
Yeah, he's from around here, isn't it?
Yeah.
Yeah, Copernicus. And then, of course, Galileo contributed to that. And then came along Kepler and Robert Hooke. And then finally, of course, Newton. Now, this was not the first day an apple actually fell to the ground. But Newton had something that most people didn't have. It's called curiosity. And he said, why? But Newton did not really define gravity. It's a misunderstood concept. What he actually defined was the really gravitational influence, the inverse law that he talked about, and how objects have actually pulled towards each other. And that's kind of what he formulated. Well, that took a long time. This was in late 1600s when this happened. Can you imagine how long that was? We waited for gravity, which is kind of obvious in schools these days, right? But they didn't know this back in 1600. Well, that's kind of fascinating to me. Well, we take time to learn. We take a long time to learn. What's the center of the celestial bodies? The sun, of course. Like, just like, are you serious? You're asking me this question, right? No, there's no trick questions. I told you there are stupid questions. But you know it. I know it.
Yeah.
Who said this first? Guy from around here.
You say Copernicus.
That's correct, Copernicus. Before the time of Copernicus, this was in 1600, you know what everybody believed? That Earth was the center of the celestial body. And you dare not say any other way, because everybody knew it. And so it turned out, it's kind of funny to think about it, that these guys were going on ships. And they looked at all the things that people have written, and they go out there and say, yeah, this is not working, is it? Because they're trying to position things, and they're going to wrong places. And they said, okay, there's clearly something wrong, but let's be quiet. Let's not talk about it, right? Because it's not safe to talk. Well, this guy Copernicus finally said, yeah, no, this doesn't seem to work. And I'm going to find out this. And he found out that Earth, not Earth, but sun is the center. But notice his system was kind of concentric circles. So it was not correct. It's okay. Great people are not right, isn't it? And then came along Kepler and he said, oh, this is actually elliptical and not a circular one. Yeah, that's awesome. But people didn't really take it. Why? Because that was not the established mainstream thing. It turns out that sun being the center of the celestial body was not mainstream until Galileo came back and said, wait a second, Copernicus said this, Kepler said this, and guess what I did? I used the telescope and looked at it, and you dudes are wrong. And they punished him. They put him in jail under house arrest, which is where he died. Bad things happen to people who speak up. That's a world we have lived in. That's mainstream. Health and church, but a friend comes to you, a lady comes to you, a good friend, and says, I'm going to have a baby in about 2 months. I'm wondering where I should have the child being born. What would be a recommendation to your good friend? What would you recommend?
Currently,
Currently.
a hospital.
That's right, currently, yeah, because you was very cautious, currently. A hospital, right? This may not be true in next few months, but currently. That's awesome. Are you a consultant by any chance?
No.
Okay, so currently, right? Well, actually, she is extremely right. Very right. Because the word currently actually is alluding to the past. Because of this friend and her was in 1850. That was like, 160 years ago? Shocking, isn't it? 160 years ago, she would have said something very different. Why? Because the mortality after childbirth was 3 times higher than having a child born at home through a midwife. Can you believe that? Scary, isn't it? And that is the way it was. And you ask why? Well, nobody knew why. This was 1800. But there was one guy who kind of thought about this. And this guy is Ignaz Semmelweis, and he's Hungarian, he said, hey, I don't know what's happening, but I wash my hands. And I didn't touch other things while I touched patients. And after I touched the patient, I went and cleaned my hands again. I sterilized stuff. And my patients don't die often. And I think there's something called germs. And they came to me and said, have you seen a germ? I said, no, I haven't. I'm just guessing. Well, why don't you guess in the prison? They killed him in 14 days. 14 days, all it took to kill him. Sorry. Because washing hands was not mainstream. And it turned out later on, Pastor, and then Joseph Lister came along and said, you know what? The dude you killed, he's actually right. We looked into the microscope. Look at that. Those are germs. And you doctors, great doctors who walk around with clothes full of blood, you are killing your patients. And it took a long time before sterilization and other practices became the current mainstream. So we need to think of the word mainstream. What is this? We hold these truths to be self-evident, that all men are created equal. Any guess where this is from? This is from my country, the Declaration of Independence of the United States. And that's what Thomas Jefferson wrote with the help of other people. And I was walking through Mount Vernon. This is the home of Washington. As I was walking through, it shocked a little bit. And they said, all men are created equal. And through the window, I look out, there are slave quarters. And I said, is this hypocrisy? How could there be slave quarters when these people defined and wrote that all men are equal? But I understand why. You cannot change a nation in one step. You can either win a war or you can win a civil war, not both at the same time. You know what happened in American history? It took another war, a bloody war, before slavery was abolished. And then another 150 years before rights were fought by Martin Luther King. It's a very long process. And you cannot win all the wars in one time. But it makes you wonder, isn't it? And Abraham Lincoln had to give his life to do that 100 plus years later. Very shocking. Well, sitting next to colored people was not mainstream back then. So we need to think of the word mainstream. It took this lady's courage and other courage. This is Rosa Parks. You can see MLK in the background, Martin Luther King. She sat in a bus and I said, no, I will not get up. I'm going to sit in this seat. And she participated in changing the world at that time. It takes courage to change the mainstream. And of course, we know about women suffrage. And I was looking through this. It turns out women having the rights like men was not mainstream. And it's still not. I put it in the parentheses. It is not still. What a sad story to think about. And I was looking at the years when different countries granted rights for women to vote. And all I could think of is this when I was reading this. I asked myself, what the heck? What is wrong with these people? Were they born with mothers? Do they have sisters? Do they have daughters? How could somebody think like this? Again, that's because that's what is mainstream. So, thinking of mainstream, I got one thing to say about it. It sucks. It really does. So I want to talk about mainstream again. So let's think about what things go wrong and we reject good ideas. And only a small minority of people pick up things. And it takes a long time, like gravity, several centuries sometimes, for good ideas and knowledge to come up. So let's think about what's mainstream in object-oriented programming. So Maria, what's mainstream in object-oriented programming? What everybody around you is doing?
Object-oriented programming.
That's correct, object-oriented programming. That is mainstream. So let's think about this. It actually was not mainstream. It is now, you're right, but it turned out procedural programming was mainstream once upon a time, not too long ago, like, 30, 40 years ago. And procedural programming was, and here's another person that I really admire. His name is Edgar Dykstra. And Dykstra wrote this fantastic article called, remember what is evil? The 4-letter word?
I don't remember.
You don't use it because Java doesn't allow you to do it. Go-tos are evil. He said go-to is evil, don't use it. In fact, so much so, Java made it a forbidden keyword. You try to use the word go-to, the compiler just spits at you, right? And then calls you by names and says, dare you not, all right? So it's a forbidden keyword in Java. You cannot use go-to, he said. So what did he say? We should be structured. And structured programming became mainstream. Have you ever programmed in structured languages before?
I'm not sure.
Yeah, it feels that way sometimes. Yeah. So then came along structured programming for a while. And then these two guys. Who are these two? This is Dahl and Nygaard, two Norwegians. They created the first language that became object-oriented. This was the roots of object programming. Can anybody wildly guess? Don't worry about being wrong. I will ask her the question, but anybody can answer it. What year did they do this? 1967. Can you imagine that? 1967. What year did object-oriented programming become mainstream? Anybody guess? 1990, give or take. 23 years. Can you imagine? 23 years. If OOP was a child, it had a terrible rejected childhood. Until it became 23, it's like, oh, look at that, right? And we kind of ignored it. You know how that feels, right, sometimes?
Yeah.
Yeah. I feel that way too a lot of times, right? Well, so when that happens, when people come to me and say, oh, in computer programming, computer science, everything changes really, really fast. And I look at them and say, yeah. What are you smoking? If 23 years is the fast in which we're going to change, that's like moving like this, right? So, yeah, that's how things are so fast. Well, then what happened? We got into this bandwagon called OOP, isn't it? Well, then it was OOP, but what did it really become? It didn't become OO, it became OO as time went on. And we all started doing this. And this gentleman here, fantastic person, Alan Kay, and what did he say? I invented the term object-oriented, and I can tell you, I did not have C++ in mind. He's had that fever too, right? Any C++ programmers in this room? You are C++. He wants to confirm. Yes, and all of you come by to get your survivor shirt. Yeah, well, no, actually, it should not be that. It's actually a fantastic language for those who are using it. We have seen these ideas, isn't it? Some of these ideas are wonderful. Have you had good ideas ever?
I guess so.
Absolutely, we all do. And we always should express. And sometimes those ideas look right in the beginning, but they don't turn out too well. Like these guys, they decided to come up with a great idea. You know, I live in a state called the state of Colorado. If anybody has read about Colorado, you know what we do? We have mountains. And we live at 6,000 feet above the ground. But we call it the high country for another reason. Because you can get really high. So you want to promote good qualities to children. You want to tell the children, don't do drugs. So these guys had a good intention. So they came up with this wonderful pencil. A 10-year-old kid took this pencil and found something that was not expected. The child started sharpening the pencil. Don't want to go there. Not a good idea. Sorry. These guys here. Know these guys? Yeah, this is where you get some coffee for a lot of price. Nice idea, putting names on the trucks, but they forgot one thing. The doors sometimes open. Or about this particular thing I came across. Coca-Cola was interested in increasing its sale in the Middle East. So they put out this ad. They showed this guy kind of like dead. He drinks Coke and look at the way he's running. And as soon as they put this ad, their sales just dropped. Nobody wants to buy Coke anymore. And they said, what's going on here? That's when they figured out these guys read right to left. Duh. So yes, things sound like a great idea in the beginning. But as we kind of get out and get a feel for it. So, what do you do every day? You said you program. Can you be a little bit more descriptive?
I'm not sure what you're asking.
Yeah, you can just stop it, I'm not sure, because my wife says that all the time as well. She's like, what are you talking about? So, but my sons do that too to me. Daddy, what are you saying? So I know that feeling all the time. I'm used to it. But I'll tell you what you do, Maria, and you tell me if this is not true. All right, here we go. You write code, true?
True.
Yeah, absolutely. And then you fix bugs.
Yes.
Yeah. And then you write more code.
Yes.
And then you fix more bugs.
Yes.
And then we write more code.
Yes.
This is called persistence. Perseverance, right? We are, see, this is my feeling about programmers. Programmers are the bravest of any kind. Because the boss shouts at you, the customers shout at you, the compiler spits at you constantly, and you wipe all that and say, I can do this. And you fix more bugs. And then you write more code. What is the sequence called?
A loop.
A loop. I like her. Awesome. Infinite loop. That's our mainstream. That's what we do. Because programmer comes to me and say, yeah, that's all great idea, but I got a question they ask me. I said, what is it? And they say, I look at this code, but how do I debug? And I tell them, I'm really sorry, but I don't spend my day writing bugs, so I don't know, right? So the point is, that's mainstream. But let's talk about functional programming a little bit. So, this guy, his name is Alonzo Church. And this was way back in time. Can somebody throw a number? What year was Lambda calculus created? Throw a number at me. 1929. Can you imagine? We're just getting excited about it. You know why? Because in 10 years we can celebrate the centennial of this. It's already time, right? Good ideas take a long time. This one has taken close to 80 to 90 years, as you can see. So back then, they didn't have computers like we do. And they were kind of curious. Hey, are things computable? They didn't know that you could actually write code and run on computers because they didn't have it like that. They had few computing mechanical machines. So they were kind of thinking about, what if we had a function? Hey, what kind of function it is? Well, today we call functions X, Y, Z. Back then they called it lambda. So not much changed, as you can see. So they called it lambda functions, lambda expressions. And they said, what if we have functions that can be evaluated by computers? When you start evaluating, then comes another problem. Would it stop? You see, these guys didn't know Venkat. Because if they have seen my code, they already know, no, it doesn't. It runs an infinite loop, right? But back then they were kind of concerned. Would a computer program halt? This is called a halting problem. And Alan's church had a brilliant student. His name was Alan Turing. And Alan Turing worked on the first problem called the halting problem. This was an exciting time. They did lambda calculus. They talked about a lot of stuff we are finally beginning to use. But what these guys did, about good 30 years later, another fine gentleman called John McCarthy said, hey, what if we write a language which will use these lambda calculus? And he created this language called Lisp. You know what Lisp is? That's the language every other language is working towards becoming eventually. One functionality at a time. And he created Lisp back in 1950s, and it's been around for a long time, used by not as mainstream, by a small group of people. But one of the cool things about this is pure functions. So what are pure functions? Well, pure functions basically are functions that don't have a side effect. Well, you've written functions. What do you think of global state? Good? Bad? You can get the support of people if you want.
I think it depends.
Yeah, it's bad, yes. How bad is it? How bad is it? Really bad? Somewhat bad?
Very bad.
Very bad.
Yeah.
Okay, you don't have to answer this in the microphone. You can tell it to me so nobody hears. Do you do it? We all do. We are kind of a bunch of shameless people, aren't we? Because we say, this is very bad. What do we do? Bring it to me, right? So we do this all the time, right? But why is it so bad? Well, if you have a function that is not, it's changing things, what happens? Well, bugs creep in. It becomes hard to test this function because every time you test it, the global state can mess you up like that, right? So bad things can happen to code. And it's very hard to predict its behavior. But let's say a function is pure. Now, what is good about pure function? A pure function that doesn't have any side effects. You send some input, it gives you an output. While this is running, it doesn't sneak around and change a variable and say, what is that, right? It doesn't really change any of its local parameters. Actually, the parameters that it passed in, it doesn't change it. It doesn't try to put a thread and say, I'll give you the result and then I'll come back and hurt you, right? It doesn't do such things. It is a pure function. What happens when a function is pure? Well, the very first thing is, let's think about this. What about mutability? Have you done mutability? Have you changed variables ever?
Yes.
Yes, we all have done. Mutability is all right, not too bad. We've done it. What do you think of sharing? Come on. Sharing is a good thing. Because mom told us, remember that?
Sharing is caring.
Sharing is caring. I like that phrase. Can I use that?
Of course.
Sharing is caring, says Maria. Absolutely. I love that phrase. Well, actually, sharing is all right. But mutability is okay. Sharing is good, mom told us. Shared mutability, really bad. That's devil's work, right? And the minute we bring shared mutability, all kinds of problems come in. But if a function is pure, what happens? Imagine for a minute. Can you help me, Maria, here? That's a pure function. So that's our pure function. She made sure it is. She verified it, wrote a test on it. Great. That's a pure function. You send an input, it sends an output. But imagine, I don't really care about this output right now, but I got another function right here. This other function is also pure. And And the compiler says, you know what? I'm going to run your code. The way you wrote the code is you wrote this and you wrote this. Fair enough? All right, when do you hold that? Excellent. So we're going to run it in this order. And the compiler says, yeah, what gives? I'm going to do that. So it runs function 1, it runs function 2. Fair enough? But on the other hand, the compiler says, oh, look what I found. This could be JIT compiler. It says, I just found out the registers right now have what's needed for this. So I'm going to run this function and then run that function. And because we don't really pass data between those two, the data that result of these two is needed much down here. You think that's all right for the compiler to do that? Because we don't really need the data until later, can the compiler do that? Seems like okay.
Not really,
Why not?
because then you have different input in here.
No, but the inputs are the inputs are not connected, right? So this is a separate function, this is a separate function. We don't need the data until later time. The input for this is separate, the input for this is separate.
Oh,
Yeah, of course.
Okay.
Right. All right. So the compiler can do that. That's called optimization. Or, thank you, the JIT compiler says at some point, hey, look what I found. I've got 2 cores over here. So I'm going to run them in concurrently. What do you think of that?
nice.
Yeah, that's right. Now you're like, awesome. Now, with multi-core processors, we can do this. Where did that come from? Functional programming. So by definition, a functional code is very easy to optimize. But I only wonder about one thing. If these code are functional, Maria, is all the other code dysfunctional? Makes me wonder. Anyway, let's look at a couple of different examples. Can you walk over here by the computer? All right. So we talked about referential transparency, which is you can move things around. Why? Because as long as the input is exactly the same, the output is exactly the same. It makes testing a lot easier, isn't it? Because as long as you send the same input, it gives you the same output. Life is good. Awesome. Now, let's talk about power of expression of functional programming. You like this movie, don't you?
I like fairy tales.
Yeah. And Finding Nemo is a fantastic movie. I loved watching that with my children when they were much younger. And it's still fun to watch that movie. Yeah. Okay. So let's find Nemo, right? So what am I going to do? I want to find Nemo. So let's write a function, can we? All right. It's pair programming. Come on over here. Yeah. Okay. So I'm going to say public, static, Boolean is the result. Find Nemo. And it's going to be a list of string of names. Are you happy with that so far? And over here, I'm going to say output. What do I want to output here? Find Nemo's results. And what do I want to present over here? Well, just to say names for a minute, right? So I want to give it some names to work with. Oh, what are these names? List of string of names. And this is going to be arrays.asList. You like fairy tales? You want to fill some of the names over here from Finding Nemo? No, I can't remember it myself. I wouldn't put that you through that. So, but we'll just ask for names. How about that? I love that names, right? Okay. So now we got to implement that code right here. So how do we go about implementing it? So let's say Boolean found Nemo, right? I can hear Dorothy, right? It's like, yay! And it says, so what are you looking for? Okay. So false. Return found Nemo, right? Now for a string name in names, you know this code, right? You've written it a million times. Yeah. So if name dot equals Nemo, oh, forgot Nemo. Nemo, not the name, that Nemo. Okay, Nemo. What do we do? Found Nemo equals true. Oh, equals true. And a break. You think it's gonna work?
I hope so.
Yeah. Okay. Oh, it didn't work. Well, because in Java we say colon, right? It's cryptic, a little cryptic, just a little. Hey, we found Nemo. Yeah. Okay, here's the question. Look at that code for a minute. She's snickering when she looks at the code. What is this?
A variable.
What do you call it normally? What kind of variable is it? A flag? A flag?
Yeah.
Yeah, actually it's called a smell. Right? It looks like a smell. So, you have written code like this before?
Sometimes.
Come on, be honest with me. We're friends now.
But I'm not friends with them.
Oh, okay, all right. Okay. That's imperative code. You tell what to do, but you also tell how to do it. Yes?
Yes.
You had said, set this variable. Start looping, one name at a time. Check that name, please. If you found it, set this flag and break out. Excuse me, what if not? Well, go back and loop again. It's low level. It's primitive. My question to you, how does that feel? I'll tell you how it feels. Can I?
Yeah.
Feels this way, right up there. Right? That's the way it feels, isn't it? Let's try this again, can we? Let's find Nemo again. This is Finding Nemo Part 2. All right, let's try this. Yeah, sequel, why not? You think they only can make sequels? Okay, so that's the code we will kind of look at and say, never do it again. And let's come back here and say, return names.stream. So we are asking for a very fancy iterator here. And then we are telling this iterator, hey, go ahead and, what are we looking for, by the way? We're looking for, you know what? Simpler than that. My little mind always goes to complexity. Contains Nemo. Really? So, Maria, come look over here. Would you do all that code in the screen or just that one line? Which one would you do?
One line. Yeah, really.
Really? Well, I'll tell you what people will do. They will do the top if they are consultant getting paid by the number of lines of code they write. The bottom if they want to go home, right? So notice, what does this look like? It looks like I'm going to get the job done and go home, right? This is declarative. Much better to write the code this way, isn't it? If I know how to press this button, there we go. So declarative style, you tell what, but you don't tell how to do it. Fair enough? It's like, hey, if I don't tell how to do it, how would it know what to do? Well, imagine you are having a problem in the kitchen. That happens from time to time, right? And when a problem happens in the kitchen, what do, Maria?
It depends on the problem.
Some problem. Think of a problem. A gnarly problem you had in the kitchen. Not like cooking problem. I'm talking about plumbing and stuff like that. Yeah. What would you do? What do you normally do?
I call a plumber.
Excellent. Because my wife calls me. And I tell her to call the plumber. You are way ahead of this curve. Excellent. Okay, so you call the plumber. So, knock, knock. The guy opens the door, and he's got a hammer on his hands. I'm like, dude, who are you? I'm the plumber who takes care of plumbing. Well, what do you have on your hand? A hammer. All-purpose hammer. This can fix every problem you have. Bam! What problem do you really have? Did it really happen?
No.
Okay, all right. That would be kind of weird, isn't it?
That would be terrible.
Terrible, oh yes, absolutely. But I call this for loop. I have a name for this for loop. I call it the jack of all for loops. You just call the for loop, it does everything for you, like that hammer. But instead, a guy shows up, he's got a little toolbox. You say, who are you? I'm the guy plumber who takes care of plumbing. Hey, come on in. He lays out his bag, puts his stuff around, and you say, what are all those? Well, this is a chisel, this is a screwdriver, this is a hammer. It's in there too, and various other things. Are you going to use all of it? He says, no, ma'am, I'm going to use what makes sense for this particular work, isn't it? So what if we have these little tools, not an all-purpose Dracula, but a little tool that would just solve one problem at a time. And the contains, it won't do everything for you, but it just that one thing. So that takes care of the control, and it says, I will do the things for you so you don't have to. So what's the nice thing? It gives a clarity, right? It's expressive, right tool, sharpest tool for the right job. Would you like that?
Yeah.
Yeah, absolutely. That's what it feels like. Well, let's double a list, can we? Oh man, you already know where we're going with this. All right, she's done it. You've done it before, many times. Yes? She's almost in tears thinking of writing the code for this. Okay, all right, let's do this. You're a good sport. Awesome. Okay, So let's try this one more time. Let's say we have a list of numbers, right? Integer. And what am I going to do with these numbers? Let's just pick some numbers. Arrays.asList. Let's say these numbers here, right? Let's actually twist this a little bit. So we have these numbers given to us. Let's start with this. And what I want to do is I want to double each of these numbers, right? So we know how to do this already. So what do we do in here? We will say, for example, we want to double these values. So we would start out by saying list of integer doubled equals new array list of integer, right? Okay, we can spare that. So that's basically where we would start out. Then we would say for int element in numbers, and then we would say doubled dot add, and then e times 2 to add it. And then when we are done with it, we would output the doubled. Does that sound familiar? Do you need a little napkin kerchief?
No, I'm good.
Yeah, I feel that way too, quite a bit. Absolutely. Now, I'm actually fearful to ask this question here. How does it feel?
Painful.
Painful. It feels dirty. Really dirty, isn't it? You go home, the children come running towards you, you say, don't touch me. I got to shower first, right? It feels like you came out of that and it feels dirty, right? Doing that, it feels really dirty. It's like some job we did, we're all kind of muddy and we got to clean up. That feels that way. Well, let's try this one more time. What I want to do here is, let's get rid of that code for a second. And what I want to do is, I want to simply say, well, I want to output. What do you want to output? Well, given the numbers, get me the stream. It's an iterator. And I want to say map to integer. In this case, well, actually, I don't care to map to integer, just a map. And I'm going to say, given an element, give me an element times 2. And because we wanted a list again, we'll kind of keep it consistent to the other code. We want to collect it back to a list again. And let's actually return the list and print it, right? That's what we're trying to do here. And right there is our a little bit more elegant code. So we say, given the collection of elements, double the values, please. So what did it feel like at this point? We just told, do this for every element. I'm not going to sit there and babysit through every element, right? So let's think about how that actually feels. So we wrote this in declarative style. Imperative style is like working with a toddler. How do you talk to a toddler, a little kid? Sweetie, hold it with both hands, take one step at a time, look where you're going. You got to give every step of instruction, right? Well, functional style of programming is like working with an adult. Well, let me rephrase that. Right? So it feels that way because we have ceding the control. We said, you take care of that. I'm not going to do it. We use a specialized function here, which is the map function. So it's a very small change in syntax. We're going to learn a little bit of syntax, but it's a fundamental difference in the semantics of how we are doing things, right? It makes a big difference in how we create the application moving forward. This takes me to what's called the tell, don't ask principle. That's a wonderful principle. I often have trouble with this principle. Have you had a chance to run into this principle before?
Yeah, I've heard about it.
Yes. And tell, don't ask principle says, don't go to an object, query for its state, make decisions, and then go back and tell to change a state. Instead, trust the objects, delegate responsibilities to it and say, you do this for me. Notice what we did in the code. We were asking the collection, give me one element at a time so I could double and add. Instead, we said, collection, I trust you. Why don't you go do the job, right? So that becomes really easy to work with. So that is the principle right there. We can also enjoy polymorphism now. Notice one big difference that you have on your hand. This code is non-polymorphic. What does the for loop do? It does exactly what you ask it to do. Loop. What about what kind of looping? Sequential. What else can I do? That's it. Whereas this one says, I'll do the mapping, meaning when given input, I will apply a function and I'll give you output. However, I won't tell you how I do it. So this gives you the flexibility that it can vary the way it is going to do things. Let's entertain the thought a little bit more. Imperative style is opaque and it hides errors. So Maria, I really want your help here. So we're going to take the next challenge here, right? So I want to perform this operation, so help me out here. We'll do this imperative, right? Don't worry about functional right now. We'll do it imperative. So find the double of the first even number greater than 3. This is one of my favorite examples. So, shall we? Yeah. Do you need a chair? You want to sit down a little bit?
No,
You're good? Yeah, I feel your pain too, but just bear with me. All right? Int result equals 0. Output the result when we are done. There's hope here, right? At the end, we're going to output the result. So for int, element in numbers. And what should we do in here? You want to type that code?
Not really.
All right. So if element is greater than 3 and, I don't want you to walk away and say, hey, this pair programming is really fun. I can say that and watch him type, right? I want you to know it's more than that, right? Just know. Yeah, you could type also a little bit. All right. I'll hold it for you. Yeah. Sorry for the English keyboard, but you're doing really well. Yeah, awesome. That's right there. Yeah, you're good. Yeah, awesome. Excellent. Thank you. Wonderful. She was not just standing there. She was on it. Absolutely. So result equals e times 2. So there you go, Maria. Are we done? Is it good? Go ahead.
I'm not sure.
You're not sure. Yeah. Anybody else? A break. We need a break. So we gave a break to this code. Now is it good?
Yeah.
There's silence, a little bit of silence, right? Nobody says, so I said, of course, no. That's like, yes. Let me think about it. Well, this code is imperative code. It is broken. Now you say, well, how is it broken? I won't tell you how it's broken right now. We'll find out. But here's what happens. 3 months goes by, 3 months after writing this code, you hear a knock on the door. You know who that is, right? Tester. We love testers, right? Knocks on the door and says, hey, I want you to know your code sucks. What's your normal response? It's like, I know it. But tell me how it sucks today. Because that's what we don't know, right? Well, what happened here? Well, we'll find out in a minute by rewriting this code, can we? So here's the declarative style. So we're going to say output again, directly to the output, numbers dot stream, and we're going to say, okay, filter for me. I'm going to write it in a little bit of an English, if you don't mind. That would be easy to express. So I'm going to say filter sample is greater than 3. And I'm going to say filter sample, and I'm going to say is even. And I'm going to say filter, well, no filtering, map, sample, double it. And finally, I'm going to say dot find first. So we asked him to do all this operation here, but we need these operations. So public static, and we're going to have a Boolean is greater than 3, takes a number as a parameter, and it simply says return number is greater than 3. And likewise, we're going to go ahead and implement 2 other versions of this. This is going to be is even, this is going to be double it, and finally, this is going to be mod 2 is equal to 0, the wonderful implementation you wrote up there, which is still important to have, and then times 2. And so what did we do just here? We wrote these 3 functions right here, and we said, given a stream, get me all the numbers greater than 3, all the even numbers, double them, and find the first. But when you run this code, there's a little bit of a surprise. Notice it didn't give us a 12. What did it give us?
Optional.
An optional. Like, what in the world is an optional? Well, first of all, let's make sure we did this correct. So 1, 2, 3, 5, and 6 I wrote. That's perfectly fine. That 6 times 2 is 12, isn't it? Now, what is optional? Optional says, you know what? I don't know if there will be a valid result. Remember that tester who came and said the code sucks? You know what that tester did, as testers normally do? Hey, let's send an empty list. Let's send a list with no number greater than 3. Let's send something with no even numbers. And testers do these kinds of stuff for us, right? Yeah, it feels that they are kind of sitting there and saying, what did the programmer forget, right? So, but this code is revealing, isn't it? It didn't have a little hidden agenda. It was kind of genuine in front of you and said, that's it. And if you want to get a value, how would you get a value out of it? Well, you can simply say get and get the value. Or you could say, I want to provide an alternative, or else maybe a 0 I can provide. That's our choice, right? But notice how the code was revealing. So, functional code is transparent. It doesn't hide behind, lurk around and say, got you, right? So a good code should read like a story, not like a puzzle. You don't like, I'm not sure, let me think through this for a little bit more. What does this code do? You read the code and it's kind of obvious. Hey, take the stream, get all the numbers greater than 3, get me even numbers, double them, and just get me the first one. What do you think so far, Maria?
Yeah.
Nice. Any kind of suspicions, objections, concerns? You can use the help of people, definitely.
Why to double all the numbers?
Yeah. She's like, why do all that extra work if all I wanted one value? That's correct. Let's go back and try this again to add that concern. She's concerned about efficiency, right? She's right on it. Awesome. Nice to work with somebody that is right in step. Absolutely. That's what happens when programmers work with programmers. All right. Did we do any extra work? It turns out there is another feature that is wonderful in functional programming that I want to share with you. There's only one other place I've seen these characteristics. Streams, like my children, are lazy to the bone. Well, my 2 boys actually are there up there, and my wife will guarantee you about this. And what these 2 guys do, they fight all the time. That's what children do, I'm told. But you know, they say that having children is when you really appreciate your parents. I do this all the time. Mom and dad are great. Well, especially with me, they were super great. I was terrible as a child. Anyway, that's another story. These guys fight, and I say, are you done with your homework? Yes, Dad. How did it go? Wonderful. Is everything okay? Absolutely. Can I see it, please? Sure. And they walk away. I don't see them for an hour. And my wife says, hey, what happened? Where are they? Did you ask for the homework? Yeah, well, they're working on it. Well, look at these streams. Very, very nice guys, though. So stream, yes. Filter, done. Filter again, done. Map, done. Find first, oh dear. And that's when it decides to do the work. Now, what will you do if you have to do something at the last minute? You won't think this much, that's for sure. You're like, I don't want to admit it, that's what you're saying, right? You do the most essential things and you get away. Yes, yeah, she's like, absolutely. Let's look at this. It appears like a lot of work. If you go back here, we're going to look at these numbers, right? 1, 2, 3, 5. All these first 3 are less than 3. 5 is greater than 3, so that's going to be 2 operations, right? But it's not even. 6 is even, so it looks like we're going to do about 7 or 8 operations on it. That's it, right? But this one looks like we're going to create an entire collection, and another collection, and another collection. And are you out of your mind, you are saying? Let's see if that's true. So let's go back over here and say output over here. We'll call it as EGT3 for, and we will say number. We will do this one more time for is even and for double it. And in here we will say is even, and then we will here say double it, and go ahead and run it. And notice what happened. It only did enough work, isn't it? It never looked at the other numbers. In fact, if you go back over here for a minute and remove this last step, right, and run the code, notice none of those actually worked. You know how that feels, right? It's like, hey, where's the boss? He's not at work today. Yay. True? The way she laughs, it appears like, right? I got to call those guys now and do some checking with them. Is it the way it is, Maria? Hey, is the boss at work? Yeah. Well, darn it, I got to do some work today, right? So that's exactly how these guys work, right? Awesome. So the bottom line is this. We got lazy evaluation in functional programming. How cool is that? But one thing to keep in mind, efficiency is attained not by doing tasks faster or better. It is actually done by avoiding those unnecessary steps that we shouldn't be doing in the first place. And so the word lazy in functional programming is pronounced as efficient. That's the right pronunciation of it. So functional programming gives us these two wonderful things, efficiency through lazy evaluation and composition. But what about speed? Let's entertain that thought for a minute. I'm going to give you a very quick example of this in the next few available minutes. Are you up for it? All right, let's go for it. So I'm going to go back to one example I want to try out here, and I'll call this as the stock example. So what I have here, of course, right? So what I have here is a variable called the default stock info. And that's just a stock info object. We don't have to go into the details right now. You know this loop? I loop through one stock at a time, get a stock price, and assign it to this variable. And my goal is to find the biggest stock price less than $500. And what do I do here? I check if the stock is less than 500. If it is, you know this very well, right? You check if the two things are bigger or smaller, you put that back into it. And we have all done this code several times. Do you agree? Yes. I mean, she's like, yes, please don't show it to me again. Okay. And then we eventually print it out, right? Absolutely. And I'm going to time that code right here. Seems like it's good. All right. Let's go ahead and run it to make sure it's actually working. So that code is working. Now, we want to do this in a imperative style rather than, declarative style. Declarative style rather than imperative style, right? Well, that code is going down to the web, getting the information for us. We'll take a note of it in just a second. But how are we going to do this declarative? Well, we already saw bits and pieces of this. We saw the filter method. We saw the map method. Filter was cherry picking objects. Map was doing the transformation. That seems like an awesome set of things to do. Hey, that's Amazon at $332.41. If somebody would notice that and write it down, we're going to need this back in a few minutes. Can I seek somebody's help? Somebody can write it down? So, or take a photo, whatever. $332.41. Excellent. 27 seconds to do it. Shall we do it in declarative style? All right, there we go. So let's change this to just stock price instead of imperative. And I'm going to go ahead and write public static void find stock price. But we're going to do a little bit different now. I'm going to pass to this guy, not the ticker symbols, but I'm going to send a stream. We've seen that a few times already, right? I'm sending the stream. So here I'm going to say stream of strings. We'll call it symbols. And I'm going to start with this for a second. So I would need a stream at this point. So import static dot, not static, java dot util dot stream dot stream. That's a new nice interface. So I'm bringing it over here. And then now that I have the stream, I'm going to say output. And what do I want to output? Well, I'm going to say symbols dot map. And I have the stock util. We use that up there already. And I'm going to ask for the get price from it. And once I get the price from it, I'm going to say filter. And I go to the stock util and say, is price greater than 500? And then the last step is reduce. And I'm going to say default stock price, stock util. And I'm going to ask it to pick the high value for us. So that is exactly what we are doing here, is we asked it to do all that work. And finally, when we are done, I'm going to ask it to print it. You're happy with that so far? So let's understand what we did. We said, given the symbols, get me all the stock prices, filter out those that are less than 500, and reduce it to the highest stock price, right? So this is declarative. Why? It reads like the problem statement, reads like English, or whatever language that's favorite for you. And as a result, this code is not hiding things. It's very transparent, isn't it? Which one do you like of the two, once you get used to it? Second one, absolutely. Well, of course, we're going to run through this and find out what it does, but I want to entertain a thought while this is doing it. Well, it's going out to the web, getting the price, and is the price the same? Yes. Maria, I have sad news for you. Just because we write better code, we don't get better stock prices. And even if the stock prices are really good, the big guys take the money, not us, right? But we get the pleasure of writing the code the way we do, right? Absolutely. What about the time? It's about the same, isn't it? Not much. So far, so good. But you're on this project. Let's see that we're writing code like this. And you are 3 months away from the release. You know, the tester walks in and says, oh, we got a problem. What now? Well, okay, I know my code sucks, but tell me how. And the tester says, well, I ran this with a large number of input, and the performance sucks. Remember that day? Well, let's move over there and talk about it. We don't want to be close to the computer talking about it. So you're thinking, what can we do to improve the performance? Are you thinking? Yes. And suddenly one of the fellow developers says, I've got a bright idea. And what do you say? You say, okay, what's it now? Well, we got multi-core processors. Imagine this. We could run this on multiple cores, right? It seems like awesome, right? And you're saying, oh, wait a second. And you think about this. And you look at this code. What does it do? A for loop, mutable state, shared mutable state, all that stuff. And you're thinking the last job you had. Remember that? There was a sequential code, and they told you use multi-threading to improve performance, and you introduced threads, and when you did the code look like the same code as you had before? No. What happened to that code? It turned into a monster. Remember that? And every single day you came to work thinking, how the hell am I going to fix this bug? And while you're fighting that code, you update your resume and apply for the next job. That's called concurrency. Remember that, right? Because when you do, the code completely changes shape, and it becomes unmaintainable. And as a result, it becomes extremely painful to work with the code. But what we could do instead is we don't have to change our code structure. And all we did was we said, you know what, we've been good. We maintain functional hygiene. And as a result, it gave us the result. Is the same stock price? Absolutely, but a lot less time. And because we had functional hygiene, we were able to make this code work a lot easily in multi-threading. And why did we achieve that? How did we achieve that goal? Because of functional purity. And because the functions were pure, we didn't mess up with any global state. It became a lot easier to change that along the way. So let's think about mainstream. We have all enjoyed the mainstream, but it's time for us to rethink our mainstream. Towering geniuses disdain a beaten path. It seeks regions hitherto unexplored, said Abraham Lincoln. Imperative code is very familiar to us. It's mainstream. Declarative code is simpler and easier to work with. In what ways? It is concise. It is expressive. It is something that keeps us focused. It is something where the code begins to read like the problem statement. It is transparent. It is not lurking behind and saying, I'll hurt you when you don't expect the least. It is easier to test due to the purity of the functions, and it's easier to optimize it, and it makes concurrency fairly simple. But all these things available to us, this has been around for a very long time. It came to Java recently, but the concepts are very, very old and proven and has been worked. But I'm going to say the biggest change is not in the languages after all. The biggest change is in our world, is in the minds of us, the programmers. We must be willing to move away from the mainstream and adopt to better things. I hope you found that useful. Thank you. Thank you very much. Appreciate it. Give her a big round of applause. Thank you.